Yeah, so I'm today here to bring in the car OEM perspective, and I would really like to show you how we can bring cooperative safety to micromobility and why it is so important. So we just have heard it, urban mobility is changing. Cycling, micromobility, they are growing, and they are an essential part of our daily life. And as the mobility is changing, the safety must keep pace. If we are looking into passive safety in cars and micromobility, we see if you're driving a car, you're protected by tons of metal and airbags and so on, while cyclists, in the best case, wear a helmet. And as they share the same public space, cars are often a danger for cyclists. When we're looking to accident statistics in Europe, we see that for a long time, accident numbers and fatalities kept falling. But in the recent years, like 2013, 14, these numbers began to stagnate. And there was a goal in 2018 by the European Commission to reduce the number of fatalities until the year 2030 to the half. And we see it here in the gray line. We are missing this goal. And if you're looking to accidents we are used in cars, we see they are mainly happening in urban areas. And most often in accidents between cars, bicyclists and motorcyclists, these accidents happen in intersection junctions. I have here also a more detailed view on the accidents, here from Germany only, but we can clearly see that the accidents involving personal injury even rise in the past years. And we see here the number of cyclist accidents has a little bit reduced, but we have new forms of mobility. We have e-bikes, we have e-scooters, and so on and so on. And thereby, the numbers increase. So why do accidents happen? Mainly we have two options there. A car driver failed to look, or he looked, but he failed to see. So maybe there were obstructions or something like this. And therefore, car OEMs developed active safety systems. And ADAS with onboard sensors have significantly improved road safety during the recent years, especially with technologies like AEB. But they have physical limits. So if we imagine we have a crossing situation where your sensors are obstructed by parking cars or something like this, even if you have a 360-degree sensor, perfect sensor, you probably wouldn't be able to detect every road user. And for many scenarios, sensor-based systems are highly effective, but they can be limited. And therefore, we need connectivity between road users and cars. By sharing information about your location, the car can see you also through visual obstructions. But how do we connect VRUs and cars? So mainly we have two ways. We saw it yesterday in the presentation of Rasvan. I will quickly go through it just to explain. We have cloud-based communication and we have direct communication. Cloud-based communication is great if you want to aggregate data and you really need long-range communication. For example, you want to make route planning and stuff like this, but it has its limitations, especially when we're talking about latency and availability and so on and so on. When we're connecting road users directly with direct communication like IDSG5, we gain some benefits. We have a reliable connection with low latency, and these are really suitable for safety applications. You see it here, cloud-based communication is limited to HMI currently, in our opinion, to use cases like awareness. You want to say to the driver, there's an event and be careful. But for classic safety applications, like we have active safety applications with warnings and even reactions, we need direct communication. And currently, direct communication is limited to non-safety critical interventions and reactions, but there's some work to also include safety critical interventions that need functional safety. So what is currently on the road from Volkswagen? So in the V2N communication, cloud-based communication, we have traffic and hazard information. We are using event-based information for route planning and so on and so on. And it's already integrated in route navigation in many models. But we also deployed direct communication in Europe. And we have now over 2 million vehicles equipped with V2X direct communication on European roads in more than 12 models and 3 brands. And we have several use cases where we already today are communicating between vehicles and the infrastructure. And we also started to integrate the first reactions on events. For example, we have an ACC reaction on the end of traffic jams. And this is possible by only connectivity. But how can cars see bikes and bikes see cars now? So there are 2 principles, cooperative awareness and collective perception. By cooperative awareness, you need to equip your VRU with an onboard unit. And this onboard unit will share its location with the car and further information. But we have also the possibility to integrate collective perception. Thereby, you will use your sensor data and share it between cars or from infrastructure to car, like we've seen it in the city of Vienna. And we really need all these principles to cover all road users, because not every cyclist will be equipped with an onboard unit, and not all the time there will be a car seeing a cyclist and sharing its location with other cars, and not on every intersection there will be a smart sensor sharing its sensor data. But if we are combining all these principles, we can really reach experienceability and safety. There was a study from Continental, and they studied how V2X enhanced ADAS will address vehicle versus VRU crashes 15 years after mass deployment. And they assume that e-bikes will not be, will not have an OBU, but things are changing a little bit. We see C4CS and so on and so on. So this is quite pessimistic. There might be some more potential in it. And they said with onboard sensors, we are only capable of solving 55% of all accidents in our data set. 15 years after mass deployment, 7% more will be solvable by cooperative awareness, and again 16% more will be solvable by collective perception. They made some assumptions. Please look in the paper for details, but I think there's a huge potential in it. But how we can do it and how we can address these use cases or this information in the cars, we need to integrate it into our active safety system. So one opportunity is, and this would be a first step, to raise awareness about crossing road users. By raising awareness, we are like looking a little bit more into the future than with classical warnings. We don't want to annoy the driver, but we have the benefits of V2V because we can see cyclists earlier than our sensors do. And therefore we can say, okay, be careful, in 5 seconds there is a road user crossing, slow down, and you will not need safety critical intervention from your ADAS if the driver is following these warnings. if you're looking 2 steps forward, we can also integrate V2X information into our AEB systems. I've already said these are safety critical interventions and we need functional safety, but there's also acceleration values where you don't need functional safety, and it's there was a paper from Bosch and they proposed a 2-stage V2X enhanced brake, like you do with 2 seconds TTC, this V2X soft brake with like 3 or 4 meters per square second, and once you see the VRU, you will do full classic AEB brake. And they did a simulation study on this with real-world crashes, and they found out, okay, we can only cover 40% with our sensors-only systems, but with assumption 100% penetration rate of V2X, we can cover up to 80% of all crashes and can address them. And I think this shows, again, really high potential. But what is needed there? We need high reliability and accuracy of our positioning systems to make robust implementations there. So last step, how did we get from lab to road? So mainly I want to show you we are ready. We have a scalable and interoperable system. The standardization is complete. We have bicycles and motorcycles already in our profiles in the car-to-car communication consortium. And we have a proven technology which is on the road. And we have a strong foundation. We have already 2 million vehicles equipped with V2X on European roads. And we have thousands of trusted roadside units already operational. And in the recent years, we also started to make powerful partnerships. We have the Connected Motorcycle Consortium we saw today. We have C-Roads for the infrastructure. We have the Car-to-Car Communication Consortium. And since 1 or 2 years, also the Coalition for Cyclist Safety with several partners here. So we start to expand the ecosystem to include micromobility. But what is missing? So mainly, it's not more a technical question, it's more like a business question. And you need to create consumer awareness by, for example, integrating V2X into consumer tests like NCAP, and we need visible customer benefits. And thereby always can help also policy support. And since we are almost ready to deploy, I'd like to close with the statement of this conference: deploying today, empowering tomorrow.